Hello and welcome to Aviation 101 with Laura. I am coming to you with more from Task C, Weather Observations, Analysis, and Forecasts. This is my ongoing series where I am going through a simulated aircraft dispatcher oral exam with questions, and then another version of the video will include me trying to answer these questions. So acting as the examiner and then acting as a student, applicant, answering the questions. So last time, and I encourage you, please go check out the first one on Task C because there was a lot that I covered. But this is going to continue with some of the items listed in objective subpoint 2, and then continuing on with pilot reports, and we will get into surface analysis and more of the following: significant weather, prog charts, and winds aloft. Again, this is a somewhat long series because it is really just a lot. As aircraft dispatcher oral exam, you're going to have to know your weather, and that is going to be really evident if you don't know your stuff on this part of the oral. Okay, so let's go ahead, and I'm going to go on Aviation Weather Center, which is aviationweather.gov. You can go ahead and follow along. I'm going to go to the PIREPs, and we'll pull up some PIREPs and load it, and we get a fair amount of PIREPs, but if I make the window longer, we can get a lot more pilot reports. Okay, so we'll switch over to me being the examiner here. All right, could you read this pilot report for me that I've highlighted here? Sure. Okay, so this is a normal priority pilot report. They are 2 miles north of Austin Airport, and it was at 1350 UTC. Aircraft was at 1,800 feet MSL. It was a CRJ 900. The sky condition is broken clouds at 1,800. Tops were unknown. They apparently don't have any wind information, no turbulence information was given, and no low-level wind shear was reported by this flight either. Okay, cool. How about you read this one for me? Okay, no problem. This one is another normal pilot report. It's over the Abilene. Actually, it's on 360 degrees from the Abilene VOR, that's north, at 35 nautical miles. It came out at 1408 UTC. Aircraft was at 10,500 feet MSL. It's a SR-22, that's a Cirrus. Was clear. The visibility was 10 miles. The temperature was 12 degrees Celsius when this pilot made the report. They've recorded the wind from 100 at 5 knots, no turbulence, and the remark was it was hazy. Okay, excellent. How would you know if one of these pilot reports were an urgent pilot report? Okay, if it were an urgent pilot report, it would be delineated by UUA in the beginning part of the pilot report. And I don't see any on this list today. We can go look for another area. Please tell us about this pilot report then. Okay, I'm not familiar with FBC VOR, but the aircraft was 330 degrees at 25 miles. Like we said, this is an urgent pilot report. It was at 1310 Zulu. It was at 36,000 feet. It is, I do not know the specific E125. I think it's an Embraer derivative. There was mountain wave activity. The aircraft gained and lost 100 feet. And the remark is there is no damage, no injuries, thankfully. And ZOB, that's just the center code of where it was reported to center. Okay, tell me about this pilot report there that I highlighted. Okay, so this one's a little unique. You notice it doesn't say UA. It's the ARP, that's an aircraft report. That's United Airlines Flight 1269. This is its latitude and longitude. This came in at 1236 UTC. The aircraft was at 33,000 feet, and looks like the wind was from 300 at 86 knots, and they were getting continuous light chop of turbulence in clouds. Okay, awesome. Good job reading your PIREPs. Thank you. Okay, well, let's go on to some other areas. So let's look at my decision support imagery, and we're going to take a look at the prog chart. So I'm going to click prog chart and then forecast hour of 0000, and this is going to give me essentially my surface analysis chart. And so let's ask some questions about that. Okay, so what is the surface analysis chart for, really? Well, okay, the surface analysis chart shows us the current positions of fronts and pressure systems. It shows isobars, and then this version also shows where there is likelihood and probability of various weather phenomenon. So, yeah. Okay, awesome. And what is the significance of these H's and L's then on here? Yes, okay, the blue H's is areas of higher pressure, and L are areas of lower pressure. Okay, what are these gray lines, like this one that I'm tracing out here? What are those? Those are isobars. So those are lines of equal barometric pressure. And like this one that we're tracing, for example, okay, if I continue following that line, we actually have it labeled as it's 10, 12 millibars of barometric pressure along that line. So that's an isobar. What's the significance of isobars being closer together, like up here over, looks like Canada, north of Wisconsin and Michigan? Okay, closer spaced isobars is a stronger pressure gradient, so that typically indicates stronger surface winds. And in this case, these isobars are all centered around this low pressure area, and that center of the low is 990 millibars pressure. Okay, what is this front symbol that's coming out of this low pressure here? The purple one. Okay, so that purple symbol right there, that is an occluded front. So it is purple. And what is this blue line with the triangles that's coming out of there? Below that occluded front. That is a cold front. So that is cold air overtaking warmer air. So the cold front is moving there. Okay, what's the difference with this other cold front that's got like a weird dashed line going on with that one? Okay, that is frontalysis. That is where the front is breaking apart. It's dashed line and every other one has a symbol, so that's frontalysis. Okay, well, I found another weird one. What is this one that's on northern Minnesota? There's like every other one, so what is that? Ah, okay, that's frontogenesis, and that's the formation of a cold front. And on that one, it is a dashed line, but there's a triangle symbol on each one, so that's frontogenesis. So that's the formation of a cold front. Okay, what kind of front is this red one with the half circles? That's a warm front. Cool. What are these dashed lines here in West Texas and northern Mexico here? What is that? That is a trough. Ah, so what's a trough? Okay, a trough is an extended area of low pressure. What is this symbol here over the Gulf right here just south of Florida Panhandle? Ah, that is a tropical depression. It's not a hurricane, it would be colored in, and I'm sorry, it's a tropical storm. It is actually Tropical Storm Bertha, and it's labeled right there. So yeah, if it's a hurricane, it would be colored in red. Okay, cool. Good job on your the surface analysis chart, really. Okay, cool, thank you. All right, let's look at the significant weather chart since we're here. So we're gonna look at the significant weather high level chart. To get there, I'm clicking on that, going for 00, and I'll pick chart area A because that is in our part of the world in the United States. And I should also point out this chart changed in the somewhat recent past. You might have an examiner come to you with the old style of Prague chart, like if they have pre-printed weather information. I can't control that, so I would recommend looking at my video on my channel where I go over the old style of this chart, but this is the current style of the chart. And really, you should be asked about the current style. Can't predict if they're going to do that, but okay. All right, so what is this high-level significant weather Prague chart all about? Okay, so the high-level significant weather Prague chart, it tells me about weather that might affect us, and we can look at the chart to tell where it's happening, but it's at flight level 250 to flight level 600. It shows areas of turbulence, shows areas of thunderstorm predictions. It even shows heights of the tropopause, jet stream locations, and it also shows volcanic eruptions, all things that matter a lot to us flying at these types of altitudes. Okay, so what is this big black line cutting through the United States here? That's the current location of the jet stream, at least forecasted for 0000. You can see that it's 00 on the 22nd of July. So yeah, it came out at 00 on the 21st, but it's good for 00 on the 22nd. And so that's their forecast position of the jet stream. Okay, so how do you read these speed of the jet stream here? Okay. So this jet stream core is at flight level 380. That's why it says FL 380 right there. The jet stream is found, it's not just at one altitude. So you can see below that, it says 300 to 440. So the jet stream is between flight level 300 and flight level 440. But the core, like the fastest speed, is going to be, it's predicted to be at flight level 380. The pennants, each of these is worth 50, so that's 100, and then each of these marks is 10, so that's 140 knot jet stream speed, core at flight level 380. What are the little two lines on either side of this? Okay, that is speed changes of 20 knots, so it's going to be slower on either side correspondingly of the jet stream. What is this area 9 that's pointed at here? Okay, so that's pointing out an area of turbulence. So you have to go over to the little side legend to know about that. And so it is area 9 says that we have moderate turbulence between somewhere below 25,000 feet and 40,000 feet. That's the XXX thing. And then 40,000 is the top of where they expect turbulence in area 9. What's that D with the dot? That's Dallas. What's the K with the dot? That is Kansas City. What is this bubbled area here talking about with the red? Okay, so that's an area of occasional cumulonimbus, so thunderstorms, basically, between flight level 440 and somewhere below the bottom of the chart, so somewhere below flight level 250. Okay. What are these things here in, looks like, bottom part of Mexico and Central America down here? Those are volcanic eruptions happening, and actually they are labeled up here. They're Fuego and Santa Maria and their locations, so it's right there. Okay, what is this thing in the middle of the Pacific out here? It says Fausto. Okay, that is the location of a tropical storm, and its name is Fausto. What are these blue lines? Like this one here that's north of that jet stream you were telling me about. Okay, the blue lines are heights of the tropopause estimated, and that one is estimated to be at flight level 350 along that line. Okay. So let's look at the winds and temperatures aloft forecast, and you can tell me about some of those things. And how we're going to find that is go to wind and temp data, and we'll just pick my part of the country. Okay, so tell me about the wind and temperatures aloft over Mobile, Alabama at 34,000 feet. Okay, so at 34,000 feet, we can interpret this data as the wind is coming from it's forecast to be 030 from 030, so from the northeast, at 17 knots, and the temperature is negative 38 Celsius predicted. How did you know the temperature was negative? Well, it actually says right here the temperatures are negative above 24,000 feet. Okay, good. What about the wind in Birmingham at 39,000 feet? What's that predicted to be? Okay, well, that's 30 from 350, so almost north, but a little northwest, from 350 at 25 knots, and the temperature negative 51 Celsius. What about here? What does this mean? 990028. Okay, 9900 means the wind is forecasted to be light and variable, temperature negative 28 degrees Celsius. Okay, and what about here over Dubuque, where it says 811053 at 39,000 feet? How do you read that? Okay, so if the wind speed is more than 100 knots, then we have to make a modification from these from the 2-digit direction. So 81 minus 50 would be 31. So the wind over Dubuque will be forecast to be from 310 at 110 knots, and the temperature negative 53 degrees Celsius. Okay, so let's talk about the freezing level. How do you read this chart, and what is it good for? Okay, so this tells me the estimated freezing level height, and you can change the time slider at the bottom to predict it out in the future. But basically, this is telling me where the freezing level is predicted to be. It's helpful for determining where an aircraft might encounter icing. If I click the legend, then I get the freezing level heights. And so, for example, if you would, in Wisconsin, we have in the middle of the state, the freezing level is predicted to be between 11,000 and 13,000 feet today. Okay, what is a CWA? What does that stand for with regards to aviation weather? A CWA is a center weather advisory, so that is going to be issued by various air traffic control centers if there is some kind of weather phenomenon happening that doesn't meet the criteria for issuing an AirMet or SIGMET, or it is to alert people of weather happening, but it maybe hasn't reached a AirMet or a SIGMET yet. Like eventually the National Weather Service is going to issue one, but they haven't issued it yet. So that is the purpose of a center weather advisory. It can be for very similar things as an AirMet or a SIGMET or a convective SIGMET. It's just hasn't been issued yet, or doesn't meet the criteria for an AirMet, but it's still significant information for pilots flying in that local area. Okay, so we've covered a lot of these areas, but next time we're going to continue on into like field condition reports, hazard forecasts, talking about volcanic ash, talking about notices to airmen, and then looks at some of these other, we're gonna look at some of these other charts if I can find them for you guys. So yeah, hope you enjoyed that. If you want to practice, go to the video where I don't have the answers, or if you want to study, do the one that does have the answers. Thank you for watching Aviation 101 with Laura, and have a great day.